So let me show you an interesting experiment that you can do to investigate centripetal acceleration. The center of mass of the device is right here between the buttons, about here. The accelerometer is located up here. It's some distance away from the center of mass. So when this thing is tossed in the air and just allowed to rotate, this accelerometer executes circular motion around the center of mass. In other words, this. Okay, and so let's see what happens if I turn on the accelerometer and the gyroscope, and I do that one more time. So I'm going to turn this on. Okay, so let's stop that. Let's zoom in on the data over here. So we'll look at that. And so what we see here, first of all, I spun it around the z-axis. And so that's the green line here. I'm not gonna look at x or y. And so, but here, this tells me that once I let it go, the thing was spinning with an angular velocity of 23.5 radians per second. At that time, the graph at the top tells me what the acceleration was in the x, y, and z directions. Let's see if we can understand what we're seeing here. The acceleration in the z direction turns out to be basically 0. Z direction is pointing out of the face of this thing, and so there was no rotation that would cause centripetal acceleration along that direction. However, the accelerometer being here, the center of mass being there, we expect, since this thing is moving in a circle, this point is moving in a circle around that point, that there is positive x centripetal acceleration and negative y centripetal acceleration. And indeed, that's what we're seeing here. The red line is above 0, the blue line is farther below 0 because the displacement in y from the center of mass is bigger. And in fact, you can show that the magnitude of these accelerations is given by omega squared r if you do the math.